Have you ever stopped to think about what really happens while you sleep? We spend nearly a third of our lives asleep. 30 years if you live to 90. 30 years spent lying in bed with our eyes closed. At first glance, that might sound like a huge chunk of time simply gone. But the truth is, sleep is anything but wasted time. It's one of the most active, intricate, and essential parts of our existence. Every night, as the world around you quiets down, your body and brain shift into a different kind of rhythm. It's a rhythm shaped by millions of years of evolution, a cycle of rest, repair, and astonishing mental creativity. Behind those closed eyes, memories are sorted and stored. Your immune system strengthens its defenses, and your mind weaves stories that can be as strange as they are revealing. In this video, we're diving deep into the fascinating world of sleep and dreams. We'll explore what really happens during the night, uncover surprising facts about how we rest, and take a closer look at the hidden processes that keep us alive, healthy, and mentally sharp. From lucid dreams to ancient sleep patterns, from the brain's nightly cleaning system to why some people dream in black and white, there's a lot more going on in those quiet hours than most of us realize. So, get comfortable, maybe even cozy up under a blanket, and let's journey together into the mysterious realm of sleep, the place where science, history, and human experience quietly intertwine every single night.
Number 1. Humans spend about 1/3 of their lives asleep. Have you ever thought about how much of your life you spend asleep? It might surprise you to learn that, on average, we spend about 1/3 of our entire lives sleeping. That means if you live to the age of 90, you'll have spent roughly 30 years with your eyes closed, resting in bed. 30 years. That's longer than many people's entire careers. Now, at first glance, this might sound almost wasteful. 30 years of doing nothing? But sleep is far from nothing. In fact, it's one of the most active and essential parts of our lives. Think of sleep not as lost time, but as maintenance time. The quiet night shift during which your body and mind are busy repairing, organizing, and resetting for the next day. Let's start with the brain. When you fall asleep, your brain doesn't just switch off like a light. Instead, it enters a complex, carefully timed cycle of activity that repeats several times through the night. During deep, non-REM sleep, the brain consolidates memories. It decides what information to keep and what to let go of.
Imagine your brain as a diligent librarian staying late after hours, sorting through the flood of experiences from your day, shelving some neatly, archiving others, and discarding the mental clutter that doesn't need to be saved. This nightly housekeeping is so important that without it, our ability to think clearly starts to unravel surprisingly fast. Studies have shown that even one night of severely reduced sleep impairs attention, decision-making, and emotional regulation. After a few nights, the effects compound, affecting everything from your mood to your immune system. That's why chronic sleep deprivation isn't just about feeling groggy. It can increase the risk of conditions like heart disease, diabetes, and depression. Meanwhile, other parts of your body are just as busy. While you sleep, your cells repair tissue, your muscles recover from daily strain, and your immune system strengthens its defenses. Growth hormone, which plays a key role in cell regeneration and recovery, peaks during deep sleep. It's like your body runs a nightly repair workshop, fixing wear and tear so you can wake up feeling restored. And then there's dreaming. During REM sleep, your brain becomes highly active again, almost as if it's awake. This is when most of our vivid dreams occur. Scientists believe these dream periods help us process emotions and integrate experiences in ways that waking consciousness can't. You could say sleep is when your mind gets creative behind the scenes, forming new connections and insights while you rest. Across different cultures and throughout history, humans have always recognized the importance of sleep, even if they didn't fully understand the science behind it. In ancient civilizations, sleep was often linked to the spiritual world, seen as a time when the soul wandered, or when divine messages could arrive through dreams. Today, we understand sleep in more physiological terms, but the reverence remains. We now know it's not a passive state at all. It's a fundamental biological process that has shaped human life for millennia. So, the next time you glance at the clock and think about cutting your sleep short to squeeze in more work, remember this: a third of your life isn't being stolen by sleep. It's being invested in keeping you alive, healthy, and mentally sharp. Those hours in bed are when your mind tidies up, your body repairs itself, and your memories take root. In a way, it's during those quiet, unconscious hours that some of the most important parts of life are actually happening.
Number 2, we dream multiple times every night. Have you ever woken up from a dream so strange or vivid that it lingered in your mind all day, and then wondered, was that the only dream I had last night? Here's the fascinating truth. We don't just dream once per night. We dream multiple times every single night. Sleep isn't one long, unchanging state. It unfolds in carefully timed cycles, like a well-choreographed dance between your body and brain. On a typical night, most people move through 4 to 6 complete sleep cycles, each lasting roughly 90 minutes. Every cycle carries us through different stages, from the light drowsiness we feel as we drift off, into deep restorative sleep, and finally into a stage called REM sleep, short for rapid eye movement. If someone were to observe you during REM sleep, they'd notice your eyes darting quickly beneath your eyelids, as if you were watching something only you could see. And in a way, that's exactly what's happening. REM sleep is the stage when our most vivid, story-like dreams take place. What's remarkable is that this dream stage doesn't happen just once. It appears in every cycle, gradually lengthening as the night goes on. Early in the night, your first REM period might last only 10 minutes or so. But as you move into later cycles, say toward the early morning hours, these REM periods can stretch to 30, 40, sometimes even 60 minutes at a time. By the time you wake up, your brain has likely produced several distinct dream sequences, each as unique as a short film. Think of it like this: every night, your brain runs its own private film festival. Each sleep cycle cues up a new screening, with you as both the director and the audience. Some dreams are quick, fragmented, and hard to recall, like a trailer you only catch glimpses of. Others are long and detailed, unfolding like a feature-length movie. And here's the intriguing part. Even though we experience multiple dreams nightly, most of us remember only one or two, if any at all. That's because the brain doesn't store dreams the way it stores waking memories. If you wake up in the middle of a REM cycle, you might recall a dream vividly, but if you sleep through it and move on to the next cycle, those dream images often fade within minutes. Scientists estimate we forget about 95% of our dreams shortly after waking. This cycle-based structure of sleep is so reliable that researchers can actually predict when you're dreaming by monitoring your brain waves and eye movements. It's been confirmed again and again in sleep laboratories. Regardless of culture, age, or personality, nearly all healthy adults pass through these same repeating stages at night. Even newborns, who sleep in shorter bursts, follow their own versions of these cycles, with REM taking up a surprisingly large portion of their rest, likely helping their rapidly developing brains. Multiple dream periods also explain why our dream experiences can sometimes feel disconnected or oddly structured. Have you ever had a dream that felt like it was composed of several episodes, like flipping between channels? That's often because your mind is stitching together pieces from different REM periods, each separated by deep sleep in between. Interestingly, the timing of these cycles affects what kinds of dreams we have. Early in the night, REM periods are shorter and tend to produce simpler, more thought-like dreams. But toward dawn, as REM stretches longer, the brain becomes especially active, and the dreams can grow more elaborate, emotional, or surreal. This is why you're more likely to wake up from a strange, intense dream in the early morning. It's the brain's most vivid creative window of the night. Across cultures and throughout history, dreams have held special meaning, sometimes seen as divine messages, sometimes as glimpses into the subconscious. But thanks to modern sleep science, we now understand that dreaming is a natural, repeating part of our nightly biology. It's not a rare event. It's happening multiple times, whether we remember it or not. So the next time you recall a single dream in the morning, remember this. It was probably just one scene from a much larger nighttime production. Your mind didn't just give you a single story. It gave you a whole lineup of midnight narratives quietly unfolding while you slept.
Number 3. We forget almost all our dreams. Have you ever had a dream that felt so vivid, so real, that for a few moments after waking you were convinced it actually happened? Maybe you were flying over a city at night, or having a heartfelt conversation with someone long gone. But then, as you reached for your phone or sat up in bed, the memory started to slip away. Within seconds, it was gone. This isn't a rare experience. It's the norm. Most of us forget almost all of our dreams. Research shows that people typically recall only about 1 to 5% of what they dream each night. That means if you had 10 dreams, you'd clearly remember maybe half of one, if that. The rest disappear almost as quickly as they appeared, fading like mist when the morning sun rises. So why does this happen? After all, dreams can feel incredibly detailed and emotionally intense while we're in them. You might navigate entire cities, talk to people who don't exist, or live through experiences that feel like they lasted for hours. But once we wake up, those elaborate narratives often vanish in a matter of minutes. The answer lies partly in how the brain processes memories during sleep. When we dream, especially during REM sleep, the parts of the brain responsible for generating vivid imagery and emotions, like the visual cortex and the limbic system, are highly active. But another region, the hippocampus, which plays a central role in transferring short-term memories into long-term storage, behaves very differently. During REM, the hippocampus is much less active than it is when we're awake. It's as if the brain is busy creating stories, but hasn't assigned anyone to file them away properly. Think of it like watching a movie in a cinema where the projector works perfectly, but no one's recording the film. That's what happens to most of our dreams. They're experienced vividly in the moment, but without the hippocampus fully engaged, those experiences never get stored in a way that allows us to recall them later. Timing also plays a huge role in whether we remember a dream. If you wake up during or immediately after a REM cycle, there's a much higher chance you'll remember what you were dreaming about. That's why early morning dreams, the ones that happen closer to your usual waking time, often stick with you more clearly. In contrast, dreams from earlier in the night are usually lost, buried under hours of additional sleep cycles. Another factor is attention. If, upon waking, you immediately check your messages, start planning your day, or jump out of bed, your brain prioritizes new sensory input and daily tasks over the fragile memory of a dream. Those fleeting images don't stand a chance. People who keep dream journals or simply spend a few quiet moments lying still after waking often report remembering their dreams more frequently. By focusing their attention on those fragile memories before anything else intrudes, they give the brain a chance to grab the dream before it fades. Interestingly, there's also variation between individuals. Some people are naturally high dream recallers. Brain imaging studies suggest that these people show stronger activity in a region called the temporoparietal junction when they're awake and asleep. This might make them more sensitive to external stimuli during sleep, leading them to wake up more often during REM cycles, giving them more opportunities to remember their dreams. Others, by contrast, may sleep more deeply through those cycles and rarely catch a dream in progress. Culturally, the forgetting of dreams has always fascinated people. Ancient civilizations often interpreted forgotten dreams as lost messages from the gods or the unconscious. In some traditions, elaborate rituals existed to help people retain or reconstruct their dreams upon waking. Today, while we might not see dreams as divine messages, the mystery of why they vanish so quickly continues to intrigue neuroscientists and psychologists alike. The reality is that forgetting dreams is not a flaw in our memory, it's part of how our brains are wired. Sleep has many vital functions, from memory consolidation to physical repair, but long-term dream storage isn't one of them. In a way, dreams are meant to be temporary, intense experiences that serve their purpose in the moment, then dissolve quietly as the waking world takes over. So the next time you wake from a vivid dream and feel it slipping through your fingers, think of it like watching clouds drift away at dawn. For a brief moment, you saw something extraordinary. Then, just as naturally as it arrived, it faded, leaving only a faint impression behind.
Number 4. Dreams often replay our recent day. Have you ever noticed how parts of your day sometimes sneak their way into your dreams? Maybe you saw a friend you hadn't met in years, and suddenly that night, there they were in your dream, sitting beside you on a train that doesn't exist.
Or maybe you spent the afternoon studying, and your dream turned into a bizarre classroom scene where the teacher had 3 heads and the chalkboard was endless. This isn't a coincidence. One of the most consistent patterns researchers have found is that our dreams often replay fragments of our recent day. Psychologists call this phenomenon the day residue effect. It refers to the way experiences, thoughts, and emotions from the previous 24 to 48 hours quietly reappear in our dreams. The content doesn't usually show up as a perfect copy of what happened. Instead, the brain tends to remix and reorganize these fragments, weaving them into new, often surreal narratives. It's as if your mind takes yesterday's events, cuts them into pieces, and rearranges them like a collage, sometimes recognizable, sometimes almost untraceable. For example, imagine you spent part of your day at a birthday party. You saw balloons, heard music, chatted with friends. That night, you might dream about a festival where the sky is filled with floating lights, or about walking through a crowd of people wearing party hats. The details aren't identical, but the emotional tone, the sense of celebration, the social energy, often carries over. Similarly, if you briefly noticed a stray cat on your way home, your brain might later drop a cat into your dream narrative without warning, as if it were a background actor in a scene your subconscious is directing. Why does this happen? One reason is that sleep plays a key role in processing and consolidating memories. When we sleep, especially during deep and REM stages, the brain actively sorts through the information we've taken in during the day. It decides what to keep, what to discard, and how to integrate new information with what we already know. This is crucial for learning, emotional regulation, and creativity. Dreaming seems to be part of this overnight mental housekeeping. By replaying fragments of recent experiences, the brain may be reinforcing certain memories or making sense of emotionally significant events. This helps explain why emotionally intense experiences, whether joyful or stressful, often find their way into dreams. If you had an argument during the day, don't be surprised if you end up dreaming about it in some disguised form that night. Interestingly, researchers have also found a delayed effect, sometimes called the dream lag effect. This is when experiences from about 5 to 7 days earlier resurface in dreams. So while the day residue effect happens almost immediately, some memories take a little longer to bubble up. Scientists think this may reflect different stages of how the brain consolidates information over time. Some memories get stored quickly, while others take longer to integrate and may resurface later during sleep. This process isn't just a passive replay. There's growing evidence that dreaming can actually help us problem solve and process emotions. For example, if you spent the day trying to work through a challenging problem, whether it's a tricky math question or a personal dilemma, you might dream about scenarios that involve similar challenges, but in metaphorical or symbolic forms. Famous examples abound. The chemist Auguste Kekulé famously dreamt of a snake biting its own tail, which inspired his discovery of the ring structure of the benzene molecule. Of course, not every dream is profound or symbolic. Sometimes your brain is simply taking the raw material of your daily life and tossing it into the dream world because it's what's most accessible. Much like how an artist might use whatever scraps are lying around to make a quick sketch, your mind uses the sights, sounds, and thoughts of the past day to populate your dreamscapes. This day-to-dream connection also explains why changes in your daily routine can influence what you dream about. If you travel to a new place, start a new job, or meet someone new, you might find those experiences cropping up repeatedly in your dreams for a while. It's your brain's way of absorbing fresh input and fitting it into your existing mental framework. So the next time you wake up and wonder why your dream felt strangely familiar, look back at your day. Chances are, the building blocks of that dream were already laid out in the hours before you fell asleep. Your brain simply took them, added its own imaginative twist,
and turn them into a nocturnal story. Dreams, in this sense, are like a nightly reflection, a soft echo of our waking lives, reshaped by the mysterious logic of the sleeping mind.
Number 5. Almost everyone dreams in color. Close your eyes for a second and picture the last dream you remember. What did it look like? Maybe you were walking through a crowded street, or standing on a mountaintop, or sitting in a classroom that looked almost, but not quite, like the one you remember from school. Now think about this. Did you see it in color? For most people, the answer is yes. Contrary to the popular belief that many people dream in black and white, research has consistently shown that the overwhelming majority of us dream in full color. In fact, only about 12% of people report experiencing dreams without color. For everyone else, our dreamscapes are painted in shades just as rich and varied as the waking world. What's fascinating is that many of us don't even notice the colors in our dreams. We tend to focus on the story, the emotions, or the strange logic of what's happening, rather than the visual details. But if you've ever woken up from a particularly vivid dream, say, walking through a forest with golden sunlight filtering through the leaves, or standing in a city where the signs glowed neon pink, you've probably caught a glimpse of just how strikingly colorful dreams can be. This naturally raises the question, why do some people dream in black and white at all? It turns out, the answer may have less to do with biology and more to do with culture and media. In the mid-20th century, when television was still largely black and white, surveys found that a much higher percentage of people reported dreaming without color. In the 1940s, for example, studies in the United States suggested that around 3/4 of dreams were described as monochrome. But as color TV became more widespread, the number of people reporting black and white dreams began to decline dramatically. Psychologists believe that the kind of visual media we're exposed to can shape how our brain constructs dream imagery. Just as the music you listen to can influence the soundtrack of your dreams, the visual language you're surrounded by seems to leave an imprint too. People who grew up watching black and white television sometimes continued to dream that way, even decades later, while younger generations raised on color media almost exclusively dream in color. This doesn't mean that dreaming in black and white is abnormal. It's simply less common today. For some, monochrome dreams might reflect their early formative experiences with media. For others, it might have to do with how their brain encodes visual information, or how vividly they tend to remember their dreams in general. It's also worth noting that even those who primarily dream in color might occasionally experience black and white dreams, and vice versa. Dreams are unpredictable, and their visual settings can change based on emotional tone, memory, or even sleep stage. Some people report that emotionally intense dreams seem to come with heightened color saturation, almost like someone turned up the contrast knob in their minds. Others say their dreams sometimes shift from black and white to color mid-story, a phenomenon that's both rare and oddly cinematic. Think The Wizard of Oz transitioning from the sepia-toned Kansas to the dazzling Technicolor of Oz. Another interesting angle is how little we tend to reflect on the visual qualities of dreams unless prompted. If you ask someone about their dream, they're more likely to tell you what happened than to describe what it looked like. This suggests that our brains prioritize narrative and emotional content during recall, not the visual atmosphere. Yet the colors are often there all along, quietly painting the backdrop of our subconscious stories. Dreaming in color also fits into a broader understanding of how the brain works during REM sleep. This stage of sleep activates many of the same brain regions involved in visual perception when we're awake, especially the occipital lobe,
at the back of the brain. In other words, when you dream, your brain isn't passively recalling images, it's actively constructing a visual world using the same neural machinery you rely on when your eyes are open. The result can be landscapes, faces, and colors that feel as real as anything you've ever seen in waking life. So, the next time you wake from a dream, take a moment to pause before jumping out of bed. Try to recall not just what happened, but what it looked like. You might be surprised by how vivid the colors were. The blue of the sky, the red of a dress, the green of a forest. For most of us, dreams aren't muted or washed out. They're bursting with color, shaped by memory, culture, and the astonishing creativity of the human brain.
Number 6. REM sleep brings vivid dreams while our body is motionless. Picture this. You're fast asleep, deep in the middle of the night. In your dream, you're running through a forest, the ground soft beneath your feet. Or maybe you're flying high above a city, the wind rushing past your face. It all feels incredibly real. Your heart might even be racing. But if someone looked at you from the outside, they'd see something entirely different. You lying peacefully in bed, barely moving. This curious contrast, an active, imaginative mind inside a still, sleeping body, is one of the most fascinating features of REM sleep, or rapid eye movement sleep. REM is the stage of sleep most strongly associated with vivid, story-like dreams. It's named after the quick, darting movements our eyes make beneath closed eyelids during this phase, almost as if we're watching the scenes of our dreams unfold. What's remarkable is that during REM sleep, the brain lights up in a way that's surprisingly similar to when we're awake. Certain regions involved in vision, emotion, and memory, like the visual cortex and limbic system, become highly active. Meanwhile, the areas of the brain responsible for logical reasoning and decision-making, like parts of the prefrontal cortex, quiet down. This combination is a perfect recipe for the kind of vivid, emotionally charged, and often illogical stories that define our dreams. It's why you might accept something totally bizarre in a dream, like chatting casually with a talking dolphin, without questioning it. Your brain's editor is offline, but the director is in full creative mode. But here's the part that's even more fascinating. While your brain is bursting with activity, your body is essentially paralyzed. More specifically, most of your voluntary muscles, those you consciously control when you're awake, are temporarily switched off. This phenomenon is called REM atonia, and it's controlled by the brainstem. It acts like a built-in safety mechanism, preventing you from physically acting out your dreams. Imagine if this system didn't exist. If you dreamt you were sprinting, you might actually leap out of bed. If you dreamt you were fighting a dragon, you might punch the air, or worse, your sleeping partner. REM atonia ensures that even if your mind is staging the most thrilling adventures, your body remains quietly anchored, keeping you safe and tucked under the covers. Only the parts of your body that stay active during REM sleep are a few essential systems: your eyes, which flick rapidly as you dream, your diaphragm, which keeps you breathing, and your heart and internal organs, which continue their steady work. Everything else goes still. If you've ever watched someone sleeping and noticed their eyes shifting beneath their lids, you are likely witnessing a dream in real time. This delicate balance between intense mental activity and physical stillness is so well coordinated that most of us never notice it happening. But occasionally, the system can misfire, and that's where things get interesting. Some people experience sleep paralysis, a state where they wake up mentally, but their body remains in REM atonia for a few moments. It can feel frightening. You're conscious, but unable to move,
sometimes accompanied by dreamlike hallucinations that blur the line between sleep and wakefulness. Sleep paralysis is usually harmless and temporary, but it offers a rare, unsettling glimpse into what normally happens every night without our awareness. On the other end of the spectrum, there's a rare condition called REM sleep behavior disorder, in which the usual muscle paralysis doesn't occur properly. People with this disorder may physically act out their dreams, talking, flailing, or even getting out of bed, sometimes putting themselves or their partners at risk. Studying this disorder has helped scientists understand just how important REM atonia is for our safety. Beyond its protective role, REM sleep itself is essential for cognitive and emotional health. It's strongly linked to memory processing, learning, and mood regulation. People deprived of REM sleep often experience irritability, poor concentration, and difficulty consolidating new information. The vivid dreams that happen during this stage aren't just entertaining stories. They're part of how the brain processes and integrates experiences. So the next time you wake up from a wild dream and find yourself lying perfectly still, remember what just happened. Your brain was busy crafting entire worlds, replaying memories, and stirring up emotions, all while a quiet biological safeguard kept your body still and safe. It's one of the most elegant examples of the brain and body working together in perfect harmony, an internal theater where the mind runs the show and the body stays respectfully in the audience.
Number 7. Our sleep cycles last about 90 minutes each. Have you ever wondered why sometimes you wake up feeling completely refreshed and other times you feel like you've been hit by a truck, even if you slept for the same amount of hours? A big part of the answer lies in something we rarely think about consciously: the rhythm of our sleep cycles. Sleep isn't one uniform state that we enter and exit like flipping a light switch. Instead, it moves in waves, following a repeating pattern throughout the night. Each wave, or sleep cycle, lasts about 90 minutes on average, though it can vary slightly from person to person. This 90-minute rhythm shapes everything from how deeply we rest to when we dream. Let's break down what happens during a single cycle. When you first drift off, you enter light sleep, sometimes called Stage 1 and Stage 2 sleep. This is the drowsy, transitional phase where your breathing slows down, your muscles relax, and your body begins to disengage from the world around you. If you've ever felt yourself suddenly jerk awake as you were nodding off, that little falling sensation, that's something that often happens in these early stages. Next, your body gradually moves into deep sleep, also known as slow wave sleep. Here, your brain waves slow dramatically, your body temperature drops, and your muscles are fully relaxed. This is the most restorative part of the night, the time when tissues are repaired, energy is replenished, and your immune system gets a boost. It's during deep sleep that your body does a lot of its behind-the-scenes maintenance work, making sure you wake up physically refreshed. After this deep phase, your brain shifts gears again and enters REM sleep, which stands for rapid eye movement. This is the stage most strongly associated with vivid dreaming. Your brain becomes more active, your eyes dart beneath your eyelids, and you start to experience complex, often emotional dream narratives. Unlike deep sleep, REM sleep is more about mental restoration, processing memories, emotions, and new information from the day. Once REM sleep ends, the cycle begins anew: light sleep, deep sleep, REM, and back again. And this entire journey, light to deep to dreaming and out, takes about an hour and a half.
Most adults experience 4 to 6 full sleep cycles every night, depending on how long they sleep. But here's where it gets even more interesting. The structure of these cycles isn't static. It changes over the course of the night. Early in the night, the cycles are dominated by deep sleep. This makes sense biologically. Your body prioritizes physical recovery first. As the night goes on, the balance shifts. Deep sleep periods become shorter, while REM periods, the dream stages, grow longer and more frequent. This means your longest and most elaborate dreams usually happen in the early morning hours, right before you wake up. That's why if you set an alarm at the wrong time, say right in the middle of a deep sleep stage, you can feel groggy and disoriented, a phenomenon sometimes called sleep inertia. But if you wake up naturally, often during the end of a REM cycle, you're more likely to feel alert and clear-headed. Understanding this 90-minute rhythm can actually help you structure your sleep more wisely. For example, if you need to wake up early, you might aim to sleep in multiples of 90 minutes, say 6 hours, 4 cycles, or 7.5 hours, 5 cycles, rather than setting an alarm after, say, 6 hours and 45 minutes, which would yank you out mid-cycle. This isn't a perfect science. Cycles vary slightly in length, but it can make a noticeable difference in how rested you feel. These patterns aren't unique to humans either. Many mammals exhibit similar cyclical structures, though their cycles are often shorter. Horses, for example, have sleep cycles that last around 25 minutes, while cats cycle through theirs in roughly 30 minutes, part of why they can nap so often and still seem ready to pounce at a moment's notice. The 90-minute rhythm is, in a way, like the natural heartbeat of our nights. It sets the tempo for how we transition between rest, repair, and dream. By moving through several of these cycles, our bodies and minds get both the deep restoration they need and the cognitive processing that dreams provide. So, the next time you wake up from a particularly vivid dream, remember, you've probably just completed one of these cycles. Your brain and body have been following a carefully orchestrated rhythm all night long, a rhythm that's been part of human biology for millennia, quietly guiding you through the stages of sleep, one 90-minute wave at a time.
Number 8. Sleep helps store the day's memories. Have you ever crammed for an exam late at night, fallen asleep exhausted, and then somehow remembered the material more clearly the next day? Or maybe you've struggled to learn a new skill, like playing a piece on the piano or memorizing a dance routine, only to find that after a night's rest, your performance has suddenly improved. It's not magic, it's sleep. One of the most powerful things sleep does is help us store and organize the memories we've made during the day. While your body might look motionless and your eyes are closed, your brain is anything but idle. As you sleep, it quietly sifts through the flood of information you absorbed while awake, everything you saw, heard, read, practiced, and experienced, and decides what to keep and what to let go. Scientists call this process memory consolidation, and it happens in different ways during different stages of sleep. During deep non-REM sleep, which usually occurs earlier in the night, the brain focuses on stabilizing and strengthening factual memories, things like names, places, concepts, and skills you practiced. This stage is like the filing department of a busy library at closing time. The librarians, your brain cells, take the stacks of unsorted books that arrive during the day and start putting them on the right shelves. Later in the night, during REM sleep, a different kind of processing takes place. Here, the brain becomes highly active, almost as if it's awake.
This is the stage most closely linked to vivid dreaming. REM sleep is thought to help integrate new memories with old ones, making connections that aren't always obvious when you're awake. It's like the librarians not only shelving new books, but cross-referencing them with the existing collection, linking ideas, highlighting patterns, and weaving new experiences into your personal narrative. For example, if you spent the day learning a foreign language, deep sleep will help lock in the vocabulary and grammar, while REM sleep might help you connect those words to prior knowledge or personal associations, making them easier to recall later. If you practiced a sport, deep sleep consolidates the motor skills, and REM sleep helps integrate those movements into smoother, more automatic performance. Research has even shown that if you deprive someone of sleep, especially the deep and REM stages, their ability to retain new information drops dramatically. In one classic study, students who learned material and then slept remembered far more than those who stayed awake all night. Modern neuroscience has backed this up with brain scans, showing that during sleep, the hippocampus, a structure crucial for forming new memories, works together with the neocortex, which stores long-term knowledge. It's like a relay race. The hippocampus hands off memories to the cortex for permanent storage. This nightly memory transfer is so vital that people who consistently cut their sleep short often find themselves struggling with concentration, recall, and creativity. It's not just about being tired, it's about missing out on the brain's built-in organization system. Without enough sleep, memories remain fragile, scattered, and harder to retrieve. Sleep doesn't just store memories, though. It also helps filter them. Not every piece of information from your day deserves a permanent spot in your mental library. Think about how many faces you pass on the street, the dozens of sentences you read online, or the endless bits of background noise your brain registers without you realizing. While you sleep, your brain quietly decides which of these pieces are worth keeping and which can safely fade away. This filtering prevents cognitive overload, ensuring your mind isn't cluttered with irrelevant data. What's especially intriguing is that emotional memories often get prioritized. Experiences tied to strong feelings, whether joy, fear, embarrassment, or excitement, are more likely to be strengthened during sleep. This might explain why emotionally intense events stick with us for years, while mundane details vanish almost overnight. REM sleep, in particular, seems to play a role in processing emotional experiences, sometimes softening the edges of painful memories so they become less raw when recalled later. In a way, sleep functions like the overnight shift of a highly efficient library. Deep sleep organizes the facts. REM sleep builds connections and narrative meaning, and the brain's emotional centers decide what deserves the spotlight. By the time you wake up, your mental shelves are tidier, your memories are more stable, and your mind is better prepared for a new day of learning. So the next time you're tempted to sacrifice sleep to get more done, remember, it's during sleep that your brain is doing some of its most important work. Those quiet hours are when today's experiences turn into tomorrow's knowledge. In other words, going to sleep isn't the end of learning. It's the part where everything truly comes together.
Number 9. Sleep flushes toxins from the brain. Have you ever noticed how your mind feels foggy after a night of bad sleep? It's harder to concentrate. Your thoughts feel sluggish, and even simple decisions can take more effort than usual. This isn't just being tired. Something deeper is happening inside your brain. One of the most remarkable discoveries in neuroscience over the past decade is that sleep literally cleans your brain. While you rest, your brain carries out a kind of nighttime housekeeping,
a biological rinse cycle that clears away the waste products that build up while you're awake. To understand why this matters, let's start with what happens during the day. Your brain is always busy. Billions of neurons are firing constantly as you think, move, learn, react, and process information. Like any high-energy machine, this activity produces waste. Metabolic byproducts such as beta amyloid and tau proteins, among others. If these substances accumulate unchecked, they can interfere with normal brain function. In fact, abnormal buildup of these proteins has been linked to neurological diseases like Alzheimer's. For a long time, scientists didn't fully understand how the brain got rid of this waste. Unlike the rest of the body, which uses the lymphatic system to flush out toxins, the brain doesn't have a conventional lymphatic network. It seemed like a mystery. How does this incredibly complex organ stay clean? The answer came in the 2010s, when researchers at the University of Rochester discovered what's now called the glymphatic system, a network of tiny channels that run alongside blood vessels in the brain. Think of it as a specialized plumbing system that circulates cerebrospinal fluid, a clear liquid that bathes the brain and spinal cord. During sleep, especially deep sleep, this fluid flows through the brain more actively, washing away metabolic waste. Here's the really fascinating part. During sleep, the spaces between brain cells actually expand, allowing more fluid to flow through and carry away waste more efficiently. It's like the brain opens up its alleyways at night so the cleaning crew can get in and do their work. Studies using advanced imaging in mice showed that the glymphatic system is about 10 times more active during sleep than when awake. This nightly cleaning isn't just about long-term brain health. It affects how you feel the very next day. When the brain isn't properly rinsed, those leftover waste products can impair communication between neurons. That's one reason you might feel mentally sluggish or unfocused after a poor night's sleep. On the other hand, when you sleep well, the cleaning process runs smoothly, leaving your mind feeling clearer and sharper in the morning. Over time, consistently good sleep may even help reduce the risk of neurodegenerative conditions. Research has found correlations between chronic sleep deprivation, increased beta amyloid accumulation, and higher risks of Alzheimer's disease. While sleep isn't a magic bullet, it seems to play a crucial role in preventing the brain's plumbing from clogging up over the years. This discovery has changed how scientists view sleep. For centuries, people thought of sleep mainly as rest for the body or a time for dreams. Now we know it's also when your brain literally cleans house. It's a hidden but essential form of maintenance that happens quietly every night without you even noticing. So the next time you're tempted to pull an all-nighter, remember, your brain has a cleaning shift scheduled. If you skip it, the waste doesn't disappear. It lingers. And over time, that buildup can affect both your daily clarity and your long-term brain health. In a way, a good night's sleep is like giving your brain a fresh start every morning. While you rest, an invisible crew works tirelessly to keep your neural pathways clear, your thoughts sharp, and your mind ready for whatever comes next.
Number 10. Newborn babies dream a lot. If you've ever watched a newborn sleep, you know it's a mesmerizing sight. Their tiny faces twitch, their eyelids flutter. Sometimes they smile faintly for no apparent reason. To an outside observer, it looks like a whole secret world is unfolding behind those closed eyes. And in a way, that's exactly what's happening. Newborn babies spend an astonishing amount of their sleep in the dreaming stage. In fact, about half of a newborn's total sleep time is spent in REM sleep, the phase most closely associated with vivid dreaming. That's far more than adults, who typically spend only about 20 to 25% of their sleep in REM. Why do babies spend so much time in this dreaming state? To answer that, we have to understand what REM sleep actually does. During REM, the brain becomes incredibly active. In adults, this stage plays a major role in processing memories, integrating information, and supporting emotional health. In babies, whose brains are developing at lightning speed, REM sleep seems to serve an even more fundamental purpose: building the brain itself. From the moment they're born, infants are bombarded with new sights, sounds, sensations, and experiences. Every touch, every voice, every shift of light is novel. Their brains are working overtime to make sense of it all, laying down the neural wiring that will support language, movement, vision, and social interaction in the years ahead. REM sleep is believed to be a key part of this construction process. During these dream-heavy phases, babies' brains generate a flurry of neural activity. You could think of it as the brain practicing its new skills, like rehearsing the orchestra before the first big performance. For example, the areas of the brain involved in vision are active even before a baby's eyesight is fully developed. REM sleep may give these circuits the stimulation they need to mature even before the baby can see clearly. This intense REM activity also helps strengthen synaptic connections, the tiny junctions between neurons where information is exchanged. In the first months of life, the number of synapses in a baby's brain explodes, reaching levels far higher than those found in adults. This overproduction sets the stage for later refinement, where the brain gradually prunes unused connections and strengthens important ones, a process that underlies learning and cognitive growth. It's almost as if each nap is a brain-building workshop, with REM sleep acting as the chief architect. While adults dream to process experiences they've already had, babies may dream to simulate experiences their brains are preparing to handle. And newborns sleep a lot. A typical newborn can sleep between 14 and 17 hours a day, though not in long, uninterrupted stretches like adults. Their sleep comes in short bursts of 2 to 4 hours, scattered across the 24-hour day. Since about half of that sleep is REM, that means newborns are spending 7 to 8 hours a day in a dreamlike state. Imagine that. An entire workday's worth of dreaming, every day in those first few months of life. Parents sometimes notice little twitches, smiles, or jerky movements during their baby's sleep. These are often associated with REM, when the brain is buzzing with activity, while the body remains mostly still. It's one of the few outward signs we have of the rich inner world unfolding in an infant's mind. As children grow, the proportion of REM sleep gradually decreases. By the time a child reaches school age, REM sleep accounts for roughly a quarter of their nightly rest, similar to adults. This shift reflects the brain's changing needs. As development stabilizes, the emphasis moves from building neural networks to maintaining and refining them. But those early months of REM-heavy sleep are crucial. They're part of why infancy is such a period of rapid growth, not just physically, but cognitively. Every nap is doing quiet, invisible work, helping shape the architecture of a developing mind. So the next time you see a baby sleeping peacefully, remember, they're not just resting. Behind those closed eyes, their brain is busily sketching, wiring, and rehearsing for the world ahead. Their dreams, if we can call them that, aren't just fleeting stories. They're the foundation of everything they're about to learn.
Number 11. Older adults get less deep sleep. Have you ever noticed that the way you sleep changes as you get older? Maybe your parents or grandparents often mention that they don't sleep as deeply as they used to. It's not just in their heads. As we age, our sleep goes through some subtle but meaningful shifts, especially in what scientists call deep sleep or slow-wave sleep. In younger adults, deep sleep makes up a significant chunk of the night. This is the stage where your brain's electrical activity slows down, your breathing becomes regular, and your body enters a kind of restorative maintenance mode. Think of it like the overnight deep cleaning crew for your brain and body. It's during this time that tissues are repaired, hormones that support growth and immune function are released, and memories are consolidated. Waking someone from deep sleep can be surprisingly hard. They're groggy, disoriented, and might even have trouble remembering where they are for a moment. That's how profound this stage is. But as we get older, something interesting happens. The proportion of time spent in this deepest stage of sleep gradually decreases. Researchers have observed that by the time people reach their 60s and beyond, slow-wave sleep may occupy only a fraction of the night compared to their younger years. This isn't usually because older adults need less sleep overall, but because their brains naturally produce fewer of the slow electrical waves associated with deep sleep. This reduction has real-world consequences. With less deep sleep, older adults often find themselves waking up more easily during the night. It's not uncommon for them to describe their sleep as light or fragmented. A passing car, a shift in temperature, or even a change in breathing patterns can be enough to bring them out of slumber. This lighter sleep can lead to the perception that their nights are shorter or less restful, even if the total hours in bed haven't changed drastically. Now, here's the important part. Lighter sleep doesn't mean useless sleep. Even if older adults spend less time in those slow-wave stages, sleep continues to play its vital role in rejuvenating the body and mind. The effects may be less dramatic than the deep and uninterrupted sleep of youth, but they are still real. Think of it as the difference between a heavy downpour and a gentle, steady rain. Both can nourish the soil, just in different ways. Scientists are still unraveling why deep sleep diminishes with age. Some point to natural changes in the brain's structure and chemistry, particularly in regions that generate slow-wave activity. Others highlight lifestyle factors that accumulate over time, such as reduced physical activity, medications, chronic conditions, or changes in daily routines that can all influence sleep depth. There's also evidence that the brain's internal clock, located in the suprachiasmatic nucleus, becomes less precise with age, making it harder to maintain the same robust sleep rhythms that characterize youth. This doesn't mean we're powerless. In fact, understanding this shift can help older adults make better choices to support quality rest. For example, regular exposure to natural light during the day helps regulate the body's internal clock. Gentle exercise, like walking or stretching, has been shown to improve sleep depth in older adults. And maintaining a consistent bedtime routine, even something as simple as dimming the lights and avoiding stimulating activities before bed, can help the brain transition more smoothly into restorative sleep. It's also worth noting that this change is part of a broader natural evolution of sleep architecture. Babies spend enormous amounts of time in REM sleep. Teenagers often shift their sleep cycles later into the night. And older adults see reductions in both REM and deep sleep. These are not necessarily signs of illness, but of the body's changing needs across the lifespan. Of course, persistent insomnia or sudden dramatic sleep disruptions should be discussed with a healthcare professional, since they can sometimes signal underlying medical issues. So, the next time someone older tells you they just don't sleep like they used to, you'll know there's real science behind that feeling. Their sleep may be lighter and more easily interrupted, but it's still doing the quiet, essential work of restoration, just in a slightly different rhythm than before.
Number 12. On your first night in a new place, your brain sleeps half-aware. Have you ever noticed that it's hard to sleep well on your first night in a new place? Maybe it's a hotel room, a friend's house, or even a brand new apartment. The bed might be comfortable, the room perfectly quiet, but for some reason, you toss and turn. You wake up more easily, and by morning, it feels like you barely slept at all. There's actually a fascinating scientific reason behind this, and it has to do with your brain acting a bit like a night guard. Researchers have discovered that on that first night in unfamiliar surroundings, the human brain doesn't fully let its guard down. One half of your brain, usually the left hemisphere, stays slightly more alert than the other. It's as if your brain is pulling a night shift, keeping watch while the rest of you tries to rest. This phenomenon is called the first night effect. The first night effect was first observed through sleep studies that used brainwave measurements, or EEGs, to track people's sleep cycles. When participants spent the night in a lab they'd never visited before, their brain activity showed something unusual. While one hemisphere entered deep sleep, the other remained in a lighter sleep stage, more responsive to unexpected sounds or disturbances. In other words, part of their brain was asleep, but part of it was on duty, listening for potential threats in this strange environment. This pattern might remind you of certain animals, like dolphins or some species of birds, which are known to engage in unihemispheric slow-wave sleep. That's a fancy way of saying they literally sleep with one half of their brain at a time. For dolphins, this ability is essential. It allows them to surface for air and stay alert for predators, while the other half of their brain gets the rest it needs. Seabirds use a similar trick when flying long distances. They'll let one hemisphere rest while the other keeps them on course and aware of danger. Humans can't pull off that level of brain multitasking, but the first night effect is a milder evolutionary echo of the same survival instinct. Imagine your ancestors spending the night in a new cave or a temporary shelter. The sounds, smells, and shadows were unfamiliar. A fully off-duty brain might have been dangerous in such situations. So, evolution seems to have built in a cautious compromise. Keep part of the brain on low alert just in case. This is why sleeping in a hotel room, even a luxurious one, can feel strangely restless. You might wake up at the slightest creak of the air conditioner or a car passing outside. Your brain is scanning the environment, asking questions like, "Is this safe?" Or, "Do I need to react to that sound?" Even if you're not consciously aware of it. Interestingly, this effect tends to fade by the second night. Once your brain has scouted the new territory and decided it's safe, it stops keeping watch. Both hemispheres are then able to synchronize more fully, allowing you to fall into deeper, more restorative sleep. That's why you might notice that your second night in a new place often feels much better. You wake up feeling more rested, even if nothing else in the room has changed. The implications of this are quite practical. If you travel frequently, it explains why your first night on the road often feels groggy. It's not just jet lag or excitement. Your brain is literally in a more vigilant state. Some frequent travelers try to counter this by bringing familiar objects from home, like their own pillow, a favorite blanket, or even a specific scent, to trick the brain into feeling more at ease. Sleep researchers have even found ways to reduce the first night effect in lab studies. For example, they might let participants visit the sleep lab once or twice before actually recording data. That way, their brain stops treating the space as foreign, and the sleep results are more accurate. This phenomenon also hints at just how finely tuned our brains are to our surroundings, even when we're unconscious. Sleep isn't a uniform, all-or-nothing state. It's dynamic, adaptive, and surprisingly strategic. What feels like a bad night's sleep might actually be your brain doing what it evolved to do: protect you when you're in unfamiliar territory. So, the next time you find yourself lying awake in a hotel room, staring at the ceiling, remember, it's not just nerves. It's an ancient, built-in security system quietly standing guard, making sure your new environment is safe. By the second night, that system relaxes. And finally, so can you.
Number 13. In Japan, napping at work is accepted. Imagine walking into an office and seeing several employees with their heads gently bowed, eyes closed, taking short naps right at their desks. In many countries, that might raise a few eyebrows. Some might even assume those workers are being lazy or unprofessional. But in Japan, this scene is not only common, it's culturally accepted and in some cases even admired. This practice is known as inamuri, which literally translates to being present while asleep. At first glance, that might sound like a contradiction, but the concept captures something unique about Japanese work culture and attitudes toward rest. Inamuri is essentially the art of taking a brief, often unplanned nap in public spaces or at work. You might see someone nodding off on a crowded train, a student catching a quick rest in a library corner, or even a business person dozing lightly during a long meeting. These naps are usually not deep, hours-long slumbers, but short bouts of light sleep that allow the body and mind to recharge without fully disconnecting from the environment. What makes inamuri particularly interesting is how it's perceived. In many Western workplaces, sleeping at your desk might get you a reprimand. But in Japan, a short nap at work is often interpreted as a sign of dedication. It suggests that the person has been working so diligently that they've reached a point of genuine exhaustion. Rather than being scolded, they might actually earn silent respect for their commitment. To understand why this practice developed, we have to look at Japan's broader work culture. Japan is famous for its long working hours, meticulous attention to detail, and collective sense of responsibility. Many employees work late into the night, not just to meet deadlines, but to maintain group harmony and avoid appearing less committed than their colleagues. In this kind of environment, the boundary between work and personal time can blur significantly. Inamuri, then, serves as a kind of pressure valve. It allows workers to steal small moments of rest without formally stepping away from their duties. A quick nap at one's desk is more culturally acceptable than taking a long break or going home early. It's like saying, "I'm still here, I'm still committed, but I just need a quick moment to recharge." This practice isn't limited to offices. You can spot inamuri everywhere in Japanese daily life. Commuter trains, for example, are practically moving nap zones. People lean forward in their seats, gently nodding off, and yet they almost always wake up just in time for their stop, a testament to how light and controlled these naps usually are. Students are also known to practice inamuri during lectures or while studying in libraries, briefly resting before diving back into their work. Interestingly, researchers have found that short naps, often called power naps in other parts of the world, can genuinely boost alertness and cognitive performance. A brief nap of 10 to 20 minutes can improve memory, increase focus, and enhance mood without causing the grogginess that comes from longer sleep. In this sense, inamuri isn't just a cultural quirk. It's aligned with what sleep science has been saying for years: a little rest can go a long way. Inamuri also reflects a different attitude toward public spaces and personal boundaries. In many societies, sleeping in public might be seen as unsafe or inappropriate. But Japan's relatively low crime rates and strong social order create an environment where people can nap on trains or in parks without fear. It's not uncommon to see a commuter with their bag beside them, eyes closed, surrounded by strangers, completely at ease. Of course, this doesn't mean inamuri is a free-for-all. There are unspoken rules. The nap should be discreet. No snoring, sprawling out, or using the office floor as a bed. The key is to appear as though you're resting while still being present, not fully detached. It's a delicate balance between dedication and self-care. In recent years, as discussions about overwork and karoshi, or death from overwork, have gained more attention in Japan, inamuri has also taken on new meaning. Some companies are starting to formally acknowledge the importance of rest by creating designated nap spaces or encouraging short breaks. In this way, the centuries-old practice of inamuri is evolving to fit modern conversations about work-life balance and well-being. When you step back and think about it, inamuri is a reminder that rest doesn't have to mean laziness. Sometimes it's exactly what allows us to keep going. In a culture where dedication is deeply valued, this brief, socially accepted nap is a quiet but powerful way of balancing human limits with professional expectations. So the next time you feel guilty about needing a quick break during a busy day, remember, in Japan, closing your eyes at your desk might just be a sign of how hard you've been working and how smart you are for giving your brain a moment to catch its breath.
Number 14. Before electricity, people often slept in 2 shifts. For most of us today, the idea of a good night's sleep means one thing: lying down at night, sleeping for roughly 8 uninterrupted hours, and waking up in the morning feeling refreshed. But here's something surprising. For most of human history, that wasn't the norm at all. Before the age of electricity, when the rhythms of daily life were governed by the sun, many societies actually followed a very different pattern of sleep. Instead of one long stretch, people often slept in 2 distinct segments, with a period of wakefulness in between. Historians and sleep researchers call this pattern biphasic, or segmented sleep, and it was once widespread across Europe, parts of Africa, and even in early colonial America. The pattern worked like this. After sunset, people would finish their chores, maybe share a meal or some conversation, and then go to bed not long after darkness fell. This was their first sleep. They'd rest for about 4 hours, slipping into the deep stages of slumber as their bodies cooled and the world outside grew quiet. Then, sometime around midnight or a little after, they would naturally wake up. But here's the fascinating part. This wasn't considered insomnia. It wasn't a problem at all. In fact, this period of wakefulness, sometimes called the watch or simply the interval, was a normal, expected part of the night. People might stay awake for an hour or 2 before returning to bed for their second sleep, which would last until dawn. What did people do during this in-between time? Quite a lot, actually. Historical records, personal diaries, and literature from the Middle Ages to the early modern period reveal a range of activities. Some people used this quiet stretch for prayer, reflection, or meditation, seeing it as a spiritual opportunity. Monks and devout Christians, for example, often scheduled nighttime prayers during this interval. Others took a more social approach. Families might quietly chat by the hearth, couples might use the time for intimacy, and neighbors sometimes even visited each other. In rural communities, where houses were close and nights were long, this watch period could be surprisingly lively. There are also accounts of people reading, tending to the fire, or checking on animals. It was a time of gentle wakefulness, not the wired, glowing screen kind we experience today, but a calm, almost meditative pause between 2 halves of sleep. This rhythm wasn't just cultural, it made biological sense too. Our internal clocks, or circadian rhythms, are influenced by light and darkness. Before the invention of electric lighting, night was truly dark. Candles and oil lamps offered only limited illumination, so people's schedules naturally aligned with the sun. Sleeping in 2 shifts allowed the body to adapt comfortably to the long winter nights in temperate regions, where darkness could last 12 to 14 hours. Trying to sleep straight through that entire period would have been difficult, so breaking it into 2 segments fit both the environment and human physiology. We even see hints of this pattern in modern sleep research. When people are put into conditions without artificial light, such as controlled lab studies that mimic pre-industrial environments, they often revert to a biphasic pattern spontaneously. After a few days, they begin sleeping in 2 distinct chunks, with a period of quiet wakefulness in between. This suggests that segmented sleep isn't just a cultural artifact.
It may actually be part of our natural biological tendencies. So, what changed? The big turning point came with artificial lighting, especially the widespread adoption of gas lamps in cities during the 18th and 19th centuries, followed by electric lighting in the late 19th and early 20th centuries. Suddenly, the night wasn't dark anymore. People stayed up later, reading, working, or socializing under bright lights. Bedtime shifted further toward the late evening, shrinking that long stretch of darkness. Over time, the idea of sleeping in 2 shifts faded, replaced by the single consolidated block of sleep that we now consider normal. It's fascinating to realize that our modern concept of a continuous 8-hour sleep is actually quite recent in the grand scheme of things. For centuries, segmented sleep was not only common, but practical, a natural response to darkness and seasonal rhythms. And some researchers believe that understanding this older pattern might help us rethink how we deal with insomnia today. Waking up in the middle of the night isn't necessarily a sign that something's wrong. In some ways, it's a glimpse of how humans used to sleep for generations. So, next time you find yourself awake at 2 a.m., staring at the ceiling, consider this. Maybe your body isn't broken. Maybe it's remembering something ancient, an old rhythm of first sleep, quiet wakefulness, and second sleep, passed down through centuries before the glow of electric light changed the night forever.
Number 15. Short afternoon naps, siestas, are common around the world. Picture this. The sun is high, the air is warm, and the afternoon has that unmistakable drowsy feeling. You've just had lunch, and your body seems to be whispering, "Hey, how about a little rest?" In many parts of the world, that gentle call is answered with something beautifully simple, a short afternoon nap. This tradition is known as the siesta, and it's most famously associated with Spain. For generations, people in Spanish towns and villages would close up shops and businesses for a couple of hours after lunch. Streets would grow quiet, shutters would come down, and people would retreat indoors for rest. But Spain isn't alone. Similar midday rest traditions can be found across the Mediterranean, in parts of Latin America, the Middle East, and even parts of Asia. In warm climates, where the midday sun can be intense, taking a short break during the hottest hours of the day has always made practical sense. Historically, the siesta wasn't just about indulgence. It was about adapting to the environment and making the day more productive overall. Before air conditioning and modern conveniences, working through the scorching afternoon heat was uncomfortable and exhausting. By pausing during those hours, people conserved energy and returned to their work in the cooler late afternoon and evening, feeling refreshed. Farmers, laborers, and city workers alike benefited from this natural rhythm of exertion and rest. But siestas weren't limited to manual laborers. In towns and cities, office workers and shopkeepers followed similar patterns. The day was typically divided into 2 distinct working blocks: morning, then a long lunch and rest period, and then a return to work until the evening. In Spain, this rhythm shaped not just daily routines, but even cultural habits around mealtimes. Lunch, called la comida, became the largest and most important meal of the day, followed by a restorative nap before resuming activities. While modern life has changed the pace of cities and workplaces, the siesta tradition still lingers in cultural memory. In some rural areas, shops still close in the afternoon. Even in bustling cities, older generations may continue this habit, and businesses sometimes adjust their hours accordingly.
The Spanish word siesta has even entered the global vocabulary as a symbol of leisurely, healthy rest. What's fascinating is that modern sleep science has caught up with what traditional cultures intuitively understood. Research shows that a short nap, ideally between 10 and 20 minutes, can do wonders for the brain. These brief naps are often called power naps because they can significantly improve alertness, mood, memory, and concentration without leaving you groggy afterward. That's because short naps typically keep you in the lighter stages of sleep, avoiding the deep sleep phase that can make waking up difficult. But when done right, a siesta is like pressing a gentle reset button in the middle of the day. Despite these benefits, the siesta has faced challenges in the modern world. Urbanization, rigid work schedules, and global business hours have made it harder for many people to fit in a midday nap. In Spain, for example, traditional long lunch breaks are less common in big cities today, as people work standard office hours that align more closely with the rest of Europe. But the cultural legacy of the siesta remains strong, and many still see it as a symbol of balance, a reminder that rest isn't the enemy of productivity, but often its ally. When you think about it, taking a short nap after lunch isn't laziness, it's a natural response to our body's rhythm. Human alertness tends to dip in the early afternoon, a phenomenon known as the post-lunch dip. This is partly due to our circadian rhythm and partly due to the digestive process, which diverts energy towards breaking down food. Instead of fighting that slump with endless cups of coffee, traditional cultures embraced it with a peaceful pause. So the next time you feel that wave of sleepiness wash over you after lunch, consider taking a cue from centuries of human wisdom. Close your eyes for a short nap, not long enough to fall into deep sleep, but just enough to recharge. Whether you call it a siesta, a power nap, or simply a quick rest, this midday ritual is a timeless way to restore energy, boost focus, and make the rest of the day feel a little brighter.
Number 16. Even pets dream. Have you ever watched your dog or cat sleeping and noticed their paws start to twitch? Maybe their nose wiggles, their tail gives a little flick, or you hear a soft bark, meow, or whimper escape as they doze. It's adorable, of course, but it's also a clue to something fascinating. Animals dream too. Just like us, many animals go through different stages of sleep, including the one known as REM, short for rapid eye movement. This is the stage of sleep most strongly associated with dreaming in humans. During REM sleep, the brain becomes highly active, almost as if it's awake. Eyes dart beneath closed lids, heart rates change, and breathing becomes irregular. But the body stays mostly still thanks to a natural paralysis that prevents us from acting out our dreams. Dogs, cats, and many other mammals experience REM sleep as well. Scientists have observed their brain patterns during this stage and found activity strikingly similar to that of dreaming humans. This suggests that our pets aren't just resting, they're probably immersed in their own little dream worlds. Take dogs, for example. If you've ever seen your pup twitching their legs while asleep, chances are they're running through some kind of dream scenario. Maybe they're chasing a ball, dashing across a field, or even reenacting moments from a walk earlier that day. Soft barks or growls might indicate excitement or playfulness, while a gentle wag of the tail could signal joy. It's not proof of the exact content of their dreams, of course, but the patterns are remarkably consistent. Cats have their own dream quirks. Watch closely, and you might see their whiskers twitch, their ears swivel, or their paws flex gently as if they're pouncing on something.
Given how much of their waking life revolves around stalking, chasing, and hunting, even for domesticated house cats, it's likely that their dreams mirror those instincts. In other words, that quiet, curled-up ball of fur on your couch might be off on a thrilling nighttime hunt through their imagination. The idea that animals dream isn't just a cute thought, it's backed by decades of research. As far back as the 1950s, scientists recorded brain activity in sleeping cats and discovered that when they entered REM sleep, their brain waves looked just like those of humans during dreaming. Later studies with rats showed that they replayed patterns from their waking experiences during sleep. For instance, if a rat ran a maze during the day, scientists could detect similar neural firing sequences in its brain while it slept, as if it were mentally running the maze again. This strongly suggests that animals process and rehearse their experiences through dreams, much like humans do. Why do animals dream at all? While we can't ask them directly, the prevailing theory is that dreaming serves important functions across species. It may help consolidate memories, reinforce learning, or process emotions. For animals, this could mean sharpening survival skills, like remembering routes, recognizing threats, or fine-tuning hunting strategies. Even for our domesticated pets, these ancient neural patterns remain active, playing out in their dreams. There's something deeply heartwarming about this. As we drift off to sleep at night, our furry companions may be right beside us, each lost in their own private slumberscape. While we dream about conversations, journeys, or worries from the day, they might be chasing squirrels, climbing invisible fences, or curling up in sunny spots that only exist in their minds. Interestingly, the amount and intensity of dreaming can vary between animals. Puppies and kittens, for example, spend a lot more time in REM sleep than adults. This makes sense since their brains are still developing rapidly, and dreaming may help them process the flood of new information they experience each day. You might notice that young animals twitch and vocalize more frequently during sleep. It's a sign that their brains are hard at work even in rest. Different species dream differently too. Birds have been shown to experience REM-like sleep, and there's evidence that some may replay songs they've learned during the day while sleeping. Even certain reptiles show sleep patterns that hint at more complex mental activity than previously thought. Dreaming, it seems, is not uniquely human. It's a shared trait across much of the animal kingdom. Next time you see your dog's paws paddling in the air or your cat's whiskers twitching mid-slumber, pause for a moment. You're witnessing something universal and beautiful, the mysterious inner world of dreams, not just in people, but in the animals we share our lives with. As they sleep beside us, we're all travelers in the strange landscapes of our minds, some of us chasing deadlines, others chasing tennis balls.
Number 17. Blind people often see images in dreams. Close your eyes for a moment and imagine you're dreaming. In that dream, you might see vivid landscapes, familiar faces, or scenes that make perfect sense in the moment, even if they'd seem bizarre when you wake up. Most of us take it for granted that our dreams are full of visual images, but have you ever wondered what dreams are like for people who are blind? It's a question that has fascinated scientists, philosophers, and storytellers for centuries. At first, you might assume that someone who can't see in waking life wouldn't see in their dreams either. But the reality is far more complex and beautiful. Research has shown that blind people, even those who were born blind, often experience incredibly rich, sensory-filled dreams. In many cases, they report what we might call visual imagery, though it's not always in the same way sighted people experience it. For those who lost their sight later in life, the brain retains the ability to generate visual images in dreams. If someone became blind after, say, the age of 7 or 8, their dreams often still include familiar faces, places, colors, and scenes. Their brains are simply drawing from the visual memories stored before they lost their sight. These dreamscapes can feel just as vivid and detailed as those of sighted individuals. Imagine remembering your childhood home, every hallway, every corner. Even if you couldn't physically see it anymore, your mind could still recreate it in a dream. But what about people who have been blind since birth? Here, things get even more intriguing. Although they don't experience visual images in the traditional sense, their dreams are still full of sensory richness. Instead of visual scenes, their brains weave dreams using the senses they rely on most in waking life: touch, sound, smell, taste, and spatial awareness. For example, someone who's been blind from birth might dream of walking through a city not by seeing buildings, but by feeling the texture of the pavement beneath their feet, hearing the echoes of their footsteps, sensing the direction of a breeze, or recognizing a friend by their voice. These dreams can be astonishingly detailed and immersive. In fact, many blind individuals report that their dreams can feel even more realistic than those of sighted people because they're so attuned to sensory details that others might overlook. Scientific studies using EEGs and sleep interviews have confirmed these experiences. During REM sleep, the stage most associated with vivid dreaming, blind participants show similar patterns of brain activity to sighted individuals. The difference lies in how their brains construct those dream worlds. Instead of relying heavily on the visual cortex to generate images, other sensory areas of the brain become more active, creating a mental landscape that's built from sound, touch, and spatial mapping. One of the most fascinating aspects is that the visual cortex in people who are blind doesn't simply go dormant. Especially in those who are blind from birth, this part of the brain often gets repurposed to process other senses, such as sound or touch. So when they dream, their brains still use these neural circuits, just in creative, non-visual ways. It's as if the brain takes the canvas meant for pictures and paints with sound and sensation instead. This tells us something profound about the nature of dreaming itself. Dreams aren't direct recordings of the outside world, they're works of imagination, constructed entirely inside the brain. Whether or not someone has vision, their mind has the power to create experiences that feel real, to build worlds from memory, perception, and creativity. In interviews, many blind individuals describe their dreams as emotionally rich and deeply meaningful. Some say they feel people's faces through touch in their dreams. Others talk about navigating spaces through sound alone, like echolocating bats. Some experience tactile sensations so clear that they can describe the texture of objects they've never physically encountered. These accounts remind us that the human mind is astonishingly adaptable. And for those who became blind later in life, their dreams often become a bridge between their past and present. They may dream in pictures, sounds, and tactile sensations all at once, a blending of memories and current sensory realities. Over time, the balance between these elements can shift, with non-visual senses becoming more prominent the longer they've lived without sight. It's easy to think of dreaming as a visual phenomenon, but the experiences of blind individuals challenge that idea in a powerful way. They show us that dreams are not bound by sight. They're shaped by the full range of human perception. Our brains are storytellers,
using whatever tools they have to create entire worlds behind closed eyes. So the next time you wake from a dream filled with images, remember, someone else may have experienced a dream just as vivid, only theirs was woven from sounds, textures, and emotions, rather than light and color. Dreams, in the end, are not just about seeing, they're about experiencing. And that's something the human brain never stops doing, whether awake or asleep.
Number 18. Dolphins sleep with one half of their brain at a time. Imagine if you could fall asleep and stay awake at the same time. It sounds impossible for humans, right? But for dolphins, it's just another night in the ocean. These remarkable animals have developed a way of sleeping that seems almost like something out of science fiction. They let one half of their brain rest while the other stays alert. This phenomenon is called unihemispheric slow-wave sleep. Essentially, one hemisphere of the dolphin's brain goes into a deep, restful sleep, while the other remains awake and attentive. And it's not just their brain that splits the workload, their behavior reflects this too. If you've ever seen a dolphin resting near the surface, you might notice that one of its eyes is open, while the other is closed. The open eye corresponds to the awake side of the brain, quietly scanning the environment, while the closed eye belongs to the sleeping side. It's a graceful, natural balancing act between vigilance and rest. But why do dolphins need to sleep this way? The answer lies in the unique challenges of their aquatic lifestyle. Unlike humans, dolphins can't simply lie down and breathe automatically while unconscious. Breathing for them is a voluntary action. They have to actively decide when to surface and inhale. If both halves of their brain were to shut down at once, they would lose control of this vital function, and that could be deadly. By keeping half their brain awake, dolphins maintain the ability to surface for air regularly, even as the other half gets the rest it needs. Another reason for this unusual sleep strategy is safety. Dolphins live in a vast, unpredictable ocean filled with potential threats, from predators like sharks to changes in their environment. Staying half awake allows them to keep watch, detect approaching danger, and respond if necessary. Think of it as the biological equivalent of setting a night watch, except the guard and the sleeper share the same brain. Scientific studies have revealed just how impressive this adaptation is. In controlled experiments, researchers found that dolphins could maintain this half-brained vigilance for astonishing lengths of time, up to 2 weeks, without showing the kinds of fatigue or cognitive decline that humans would experience from prolonged wakefulness. During this period, they continued to perform tasks, respond to sounds, and navigate their surroundings, all while getting rest in alternating halves of their brains. This unihemispheric sleep isn't unique to dolphins. Some species of whales use the same method, and interestingly, certain birds do as well. Migrating birds, for example, can keep half their brain awake during long flights, allowing them to rest mid-air while still maintaining flight paths and avoiding collisions. But in dolphins, this ability is especially crucial because it's tied directly to their need to breathe consciously and stay safe in an environment where letting their guard down completely could be fatal. One hemisphere of the brain will rest for a period, sometimes a few hours. Then they'll switch, letting the other hemisphere take its turn. Over the course of 24 hours, both sides get enough rest to keep the dolphin healthy, alert, and active. This cycle is seamless and automatic. It's not like the dolphin decides consciously
which side will sleep. It's simply how their biology works. You can imagine how this would shape a dolphin's nightly rhythm. Instead of sinking into a long, uninterrupted slumber like we do, they float or slowly swim near the surface, taking calm breaths, one eye closed. Their bodies are at ease, but half their mind remains on watch, listening for nearby pod members, sensing changes in water pressure, and detecting sounds that could signal predators. This ability also sheds light on just how different sleep can be across the animal kingdom. For humans, sleep is usually an all-or-nothing state. We either drift off completely or stay awake. But in nature, sleep takes on many forms, each tailored to the survival needs of a species. Dolphins' half-brain sleep is a perfect example of evolution finding a clever solution to a tricky problem: how to rest while living in an environment that never truly sleeps. It's also a reminder that sleep isn't just about shutting down. For dolphins, sleep is an active, adaptive process, a delicate balance between recovery and vigilance. They've mastered what humans can only dream of: sleeping with one eye open, quite literally, and thriving because of it. So the next time you picture a dolphin gliding peacefully through the water at night, remember that behind that serene appearance is an other half is standing guard, ensuring that the dolphin can breathe, survive, and flourish in the vast, unpredictable ocean it calls home.
Number 19. Some birds also sleep one eye open. Have you ever walked past a pond or lake and noticed a duck floating serenely, one eye closed but the other wide open? At first glance, it might look like the bird is just being cautious, or maybe it's half awake because of a noisy environment. But what's actually happening is far more fascinating. That duck isn't just dozing lightly. It's quite literally sleeping with one half of its brain while keeping the other half awake. This remarkable ability is known as unihemispheric slow-wave sleep. And it's not just the domain of dolphins and whales. Many species of birds, especially waterfowl like ducks, have mastered this technique as well. When you see a duck resting with one eye open, the open eye is connected to the awake hemisphere of its brain, which remains alert and watchful. The closed eye is tied to the sleeping hemisphere, which is enjoying a well-deserved rest. Why would a bird need to sleep this way? The answer lies in survival. Birds are some of the most vulnerable animals when they're sleeping, particularly those that rest in open spaces like lake shores or open water. Predators can strike quickly, and for a bird, the difference between life and death might be a fraction of a second. By keeping one hemisphere awake, these birds can scan their surroundings, listen for danger, and take flight at a moment's notice, all while still getting some rest. Scientists have studied this behavior closely, especially in ducks. In one classic experiment, researchers observed a row of ducks resting together. They noticed a clear pattern. The ducks positioned on the edges of the group tended to keep one eye open, scanning for threats, while those in the middle closed both eyes and slept more deeply. Essentially, the birds on the outside acted like sentinels, keeping watch over the flock. Later,
When the researchers tested how quickly each duck responded to sudden stimuli, the edge ducks, those using unihemispheric sleep, reacted significantly faster than the ones in the middle. This one eye open strategy doesn't just happen randomly, it's flexible. Birds can control how deeply each hemisphere sleeps depending on the situation. If they feel safe, say, perched in a tree away from predators, they might allow both hemispheres to sleep simultaneously, like humans do. But if they're in a more exposed environment, they switch to unihemispheric sleep, balancing rest with vigilance. It's like having an internal security system that never takes a full break. You can imagine how useful this is for migratory birds, too. Some species undertake incredibly long journeys that last days or even weeks. During these flights, certain birds have been observed resting one hemisphere at a time while still flying. This allows them to recover mid-journey without ever fully stopping, maintaining their position in the flock and staying aware of their surroundings. It's a breathtaking example of how evolution has fine-tuned sleep to match a species' lifestyle. What's especially interesting is that the hemisphere that remains awake corresponds to the opposite eye. So if a bird closes its right eye, the left hemisphere of the brain goes to sleep, and vice versa. This crossover wiring gives birds precise control over their vigilance. A duck floating at the edge of a pond, for instance, might keep the eye facing the open water awake, scanning for approaching threats, while closing the eye facing the safety of the flock. This ability also challenges the way we think about sleep itself. For humans, sleep is usually an all or nothing state. We're either awake or asleep. But for many animals, sleep is far more flexible and strategic. It's not just a time to switch off, but a carefully balanced state that allows them to meet the demands of their environment. When you watch a group of ducks resting, what looks like peaceful stillness is actually a sophisticated survival strategy at work. Each bird is making micro-adjustments based on its position, surroundings, and level of risk. Some get deeper rest in the center, while others keep watch on the edges. It's teamwork, biology, and instinct all working together. So the next time you see a bird with one eye closed and the other open, take a moment to appreciate what's really going on. You're witnessing one of nature's cleverest sleep adaptations in action. A system that allows these animals to rest and remain vigilant at the same time. It's a quiet reminder that in the natural world, even sleep can be a finely tuned survival tool.
Number 20. Migratory birds can even nap while flying. Picture this: a bird soaring high above the open ocean, gliding effortlessly on warm air currents. Beneath it, there's nothing but endless blue water stretching in every direction. There are no trees, no cliffs, no safe places to land. And yet this bird remains in the air not just for hours or days, but for months. This incredible feat belongs to the magnificent frigate bird, one of nature's most extraordinary long-distance flyers. Scientists have long known that these birds can spend weeks or even months at sea without touching land. But one mystery remained. How on earth do they sleep? After all,
Every creature needs rest, so how can a bird sleep without falling out of the sky? The answer, it turns out, is both elegant and astonishing. Using tiny brain monitoring devices attached to the birds, researchers discovered that frigate birds managed to nap while flying. Yes, you heard that right. They literally sleep in mid-air. But it's not the deep, hours-long slumber we humans are used to. Instead, these birds take ultra-short naps, usually lasting about 10 seconds at a time. Over the course of a day, these micronaps add up to roughly 45 minutes of total sleep. That's less sleep in a day than many of us get during a long afternoon meeting. Even more remarkable is how they do it. Frigate birds typically sleep using something called unihemispheric slow-wave sleep, the same technique used by dolphins and some other birds. One hemisphere of the brain goes into a restful state while the other stays awake. The awake half keeps one eye open to monitor the environment, maintain flight control, and avoid collisions. Essentially, they keep half their mind on autopilot while the other half takes a power nap. But that's not all. Sometimes frigate birds can even let both halves of their brain sleep at the same time, but only briefly. When this happens, they usually glide in a steady spiraling motion, almost like they're on cruise control. By riding warm updrafts and air currents, they can minimize the need for active wing flapping, giving their brains those fleeting moments of full rest without crashing into the sea. Why go to such lengths? It has everything to do with their unique lifestyle. Frigate birds are ocean wanderers. Unlike many seabirds, they can't land on water. Their feathers aren't waterproof, and if they tried, they'd risk becoming waterlogged and unable to take off again. That means their only option is to keep flying, sometimes for weeks on end, as they search for food far from shore. In that situation, learning to sleep in the sky isn't just convenient, it's essential for survival. This behavior was confirmed through an ambitious study in which researchers attached lightweight EEG recorders to frigate birds to measure their brain activity during flight. What they found overturned many assumptions. For instance, when the same birds were resting on land, they slept for more than 12 hours a day in long stretches, just like many other animals. But once they took to the sky, their total sleep time plummeted to less than an hour per day. Yet despite this drastic reduction, the birds remained alert and precise in their movements, showing no signs of exhaustion. This raises fascinating questions about sleep itself. How is it that frigate birds can function with so little rest? Does their brain prioritize certain kinds of sleep when time is limited? Researchers think that these short naps might be highly efficient, targeting only the most restorative stages of sleep. It's as if their brains have learned to trim the fat from the sleep cycle, taking only what's absolutely necessary to keep going. Frigate birds aren't alone in this adaptation. Other migratory birds also use unihemispheric sleep during long journeys, but frigate birds hold the record for how little total sleep they need while still flying such immense distances. Their ability to turn the open sky into a floating bedroom is one of the most striking examples of how evolution shapes behavior to meet extreme challenges. The next time you look up and see a bird gliding overhead, imagine what's happening inside that tiny head. Half the brain might be wide awake, scanning for obstacles and adjusting flight patterns, while the other half drifts into a brief but restorative nap. It's multitasking at a level humans can only dream of. And perhaps most surprisingly of all, this adaptation reminds us that sleep isn't a one-size-fits-all process. For frigate birds, sleep is flexible, strategic, and deeply intertwined with survival. In a way, their lives prove that even when you live in a world without walls or beds, high above the waves, nature always finds a way to sneak in a little rest.
Number 21. Octopuses have vivid, dreamlike sleep stages.
Imagine this. You're deep underwater, surrounded by the gentle sway of ocean currents.
In a small, rocky den, a creature with 8 arms has just tucked itself in for a nap. Its skin is calm, pale, almost blending into the seafloor. And then, out of nowhere, its entire body bursts into waves of brilliant color. Patterns ripple across its skin, deep reds, bright whites, swirling stripes, like a living light show. No, this isn't a scene from a fantasy movie. This is what happens when an octopus sleeps.
Scientists have discovered that octopuses experience not just one, but 2 distinct sleep phases, a bit like how humans alternate between deep sleep and REM sleep. Most of the time, they rest quietly in a state researchers call quiet sleep. Their bodies are still, their colors muted. But about once every hour, something fascinating happens. They suddenly enter what's known as active sleep. In this stage, their skin flashes through vibrant, shifting patterns, their muscles twitch slightly, and their brain waves start to look surprisingly similar to when they're fully awake. Think about that for a second. Their brains, which are already among the most complex in the animal kingdom, seem to be running some kind of internal program even while they're at rest. This discovery came from careful observation and brain monitoring in laboratory settings. Scientists placed octopuses in controlled tanks, allowed them to sleep naturally, and recorded their neural activity. The patterns during active sleep were so close to those seen when the animals were awake that researchers began wondering, could octopuses be dreaming? Of course, we can't exactly interview an octopus about what's going on in its mind. But the fact that their skin changes so dramatically is intriguing. Remember, octopuses use their skin to communicate, camouflage, and express emotion. The color changes are controlled by special skin cells called chromatophores, which expand and contract to create those stunning displays. When this happens during sleep, it suggests that their brains are reactivating visual and emotional circuits, almost like replaying memories. If that sounds familiar, it's because humans do something similar during REM sleep. That's when most of our vivid dreaming happens, and our brains are busy sorting through experiences, emotions, and information gathered during the day. For octopuses, this active sleep might play a similar role, helping them consolidate learning, make sense of their environment, or even rehearse behaviors. This is especially compelling because octopuses are known for their intelligence. They can solve puzzles, navigate mazes, use tools, and even recognize individual humans. So the idea that their sleep might involve a kind of dreaming isn't as far-fetched as it sounds. It suggests that some of the processes we associate with higher cognition, like memory processing and emotional integration, may have evolved in very different kinds of brains, not just in mammals or birds. Picture an octopus flashing its colors as it rests, perhaps reliving the moment it escaped a predator through a clever jet of water, or rehearsing how it cracked open a stubborn clam. We can't say for sure, but this window into their sleep gives us a rare glimpse into just how rich and complex their inner lives might be. So, next time you see a video of an octopus changing colors as it snoozes, remember, you might just be watching a creature dreaming in full, vivid technicolor.
Number 22. Sea otters hold hands while sleeping. Picture this. It's nighttime along a quiet stretch of the Pacific coast. The moonlight shimmers on the surface of the water. The waves rise and fall in a slow, rhythmic dance. And there,
gently bobbing on the sea, is a cluster of sea otters, floating peacefully on their backs, eyes closed, completely at ease. But look closely. Many of them aren't floating alone. Some are snuggled side by side, their soft paws linked together, as if they're holding hands. This heart-melting behavior isn't just for show, it's actually a clever survival strategy. In the wild, sea otters often sleep in groups known as rafts. These rafts can be surprisingly large, sometimes just 2 or 3 otters, sometimes dozens drifting together like a living patchwork quilt on the ocean. By linking paws, the otters make sure they don't accidentally drift away from one another as the tides shift during the night. Imagine taking a nap on a waterbed that's constantly moving. You'd want a way to make sure you didn't wake up a few kilometers from your friends. This behavior is especially important because sea otters don't build nests or dens like many land animals. Their entire lives play out on the water. They eat there, groom their fur there, raise their pups there, and yes, they sleep there too. And unlike seals or sea lions, otters don't have a thick layer of blubber to keep them warm. Instead, they rely on their incredibly dense fur, the thickest in the animal kingdom, with up to 1 million hairs per square inch, to trap air and stay insulated. But even with this remarkable adaptation, sleeping alone in cold, open water can be risky. Holding paws and huddling together helps them conserve heat and feel more secure. You might wonder, why not just swim to shore to sleep? Well, sea otters spend most of their time in coastal kelp forests, and rather than going ashore, they often anchor themselves to kelp. They'll wrap strands of the floating seaweed around their bodies, almost like tying themselves to a gentle natural dock. This keeps them from drifting too far, especially if there aren't other otters nearby to hold on to. This behavior also highlights something special about sea otters: their strong social bonds. While not all otters hold hands, some prefer to sleep solo. Mothers and pups almost always stay physically connected. A sea otter mother will cradle her pup on her chest as she floats, grooming its fur to keep it waterproof and making sure it doesn't drift away. If she needs to dive for food, she may even wrap the pup in kelp so it stays put while she's gone. It's both practical and tender. A reminder of how much thought goes into something as seemingly simple as bedtime. And there's another layer to this: safety. Sea otters were once hunted to near extinction for their fur, and even today they face threats from predators like orcas and sharks, as well as rough currents and storms. By sleeping in groups, they reduce the risk of being picked off by predators and make it easier to respond collectively to danger. It's a kind of nighttime neighborhood watch, but floating. So, the next time you see a picture of 2 otters holding hands, it's not just an adorable moment, it's a glimpse into a highly adapted communal way of surviving in the wild. They've turned something as ordinary as sleep into a cooperative strategy, balancing warmth, safety, and companionship in one beautifully simple gesture. In the moonlit stillness of the ocean, a pair of sea otters gently clutching paws isn't just cute, it's nature's quiet brilliance at work.
Number 23. Giraffes sleep very little, often under 30 minutes a day. Imagine standing in the middle of the African savanna at night. The air is cool, the horizon stretches endlessly, and somewhere in the distance, a lion lets out a low, rumbling roar. Under the starry sky, a group of giraffes stands perfectly still. Their long necks rise like living watchtowers above the grasslands. And here's the surprising part. Even in this calm, quiet moment, they're not settling down for hours of sleep like most mammals. Instead, they're taking the briefest of naps, sometimes adding up to less than 30 minutes in an entire day. Yes, you heard that right. These towering giants, the tallest land animals on Earth, get by on less sleep than any other mammal we know of. In the wild, giraffes don't curl up on the ground for long stretches the way lions or zebras might. Instead, they've developed a very different sleep strategy. They take multiple short naps throughout the day and night, often just a few minutes at a time. Most of these naps happen while they're standing. Their legs lock into a stable position, and their heads remain upright, making it easy to snap back to full alertness at the first sign of trouble. Occasionally, especially if they feel safe, like in a protected herd or away from predators, a giraffe might lie down and twist its neck around, resting its head on its rump in a kind of elegant knot. But this is rare and brief. Researchers have recorded giraffes sleeping like this for only a few minutes at a time, sometimes adding up to a total of about half an hour over the course of 24 hours. Compare that to humans, who ideally get 7 to 8 hours of consolidated sleep, and the difference is staggering. So, why so little sleep? The answer lies in their environment. The African savanna is home to lions, hyenas, and other predators. And while giraffes are strong, their long necks and legs make getting up from a lying position slow and awkward. If they were to sleep deeply for long periods, they'd become easy targets. By taking light, fragmented naps while standing, giraffes can remain vigilant. Their towering height gives them an advantage too. Even when resting, they can keep an eye, or rather, a distant gaze, on the horizon. There's also an interesting physiological side to this. Giraffes seem to have evolved to function perfectly well on minimal sleep. While most mammals rely on longer sleep periods for brain maintenance, memory consolidation, and body recovery, giraffes appear to fit these processes into their short naps. Studies on their sleep patterns have shown that these microsleeps are enough to keep them healthy and alert, though the exact neurological mechanisms are still not fully understood. And this pattern isn't just a nighttime behavior. Giraffes will often catch a few minutes of rest during the day, especially in safe areas or within herds. Their sleeping schedule is more like a mosaic than a solid block. Dozens of quick dozes spread throughout the day and night. Interestingly, giraffes raised in captivity tend to sleep a bit longer than their wild counterparts. In zoos or wildlife reserves, where predators aren't a threat, they might lie down more often and rest for slightly longer periods. Even then, though, they still sleep far less than most other animals. This remarkable adaptation shows just how finely tuned giraffes are to their environment. In a landscape where being alert
can mean the difference between life and death. They've found a way to get the rest they need without ever fully letting their guard down. So, the next time you imagine a giraffe on the savannah, think of this. While we humans stretch out under blankets for long nights of sleep, giraffes survive on quick power naps, always half aware, always scanning the horizon. It's a quiet, graceful balancing act between rest and survival.
Number 24. Horses doze standing up. Picture a quiet field at dawn. Mist hangs low over the grass. Birds are just beginning to sing. And in the middle of it all stands a horse, motionless, eyes half closed, breathing slow and steady. At first glance, you might think it's simply enjoying the morning calm. But look closer. That horse is actually sleeping while standing up. It sounds almost impossible, right? How can such a large, heavy animal catch any rest without collapsing? The answer lies in one of nature's most ingenious mechanical designs, something known as the stay apparatus. This is a unique system of tendons and ligaments inside a horse's legs that allows them to lock their limbs in place. Once engaged, the horse doesn't have to use any muscular effort to remain standing. Their bodies can fully relax without toppling over. This adaptation is more than just a neat biological trick. It's a survival strategy. Horses are prey animals. For thousands of years, wild horses lived in open grasslands where predators like wolves, big cats, and even humans posed constant threats. If they were to lie down for long periods of deep sleep, they'd be vulnerable. Standing sleep means they can rest lightly while staying alert. If danger appears, they can wake up and gallop away in an instant. No struggling to get up, no precious seconds lost. Of course, not all sleep is the same. Just like humans, horses experience different stages of rest. Most of their sleep happens in a light dozing state while they're on their feet. Their ears might flick now and then, their weight shifts slightly, but overall, they're calm and stable. This kind of light sleep is enough to refresh their bodies during the day or night, and it can be taken in short bursts throughout the 24-hour cycle. But there's one kind of sleep they can't do standing up: REM sleep, the deep stage associated with dreaming and essential brain maintenance. During REM, muscles lose tone and the body needs to be supported. So for this, horses do lie down, but only for brief periods, usually a couple of hours or less, over the course of a day. Interestingly, horses are careful when and where they lie down for this deeper rest. In the wild, 1 or 2 horses in the herd might lie down while others remain standing, keeping watch for danger. In a stable or pasture, domestic horses often feel safe enough to lie down more regularly. But even then, they don't spend long stretches asleep like humans or other predators might. Their sleeping patterns are spread out in many short naps rather than one long nightly slumber. You might see a horse resting for 10 minutes in the morning, another quick nap in the afternoon sun, and a bit of deeper sleep at night when things are quiet. This fragmented sleeping schedule is perfectly suited to their lifestyle as prey animals in open environments.
And if you've ever walked by a barn and seen a row of horses standing quietly, heads lowered and one hind leg cocked, you've probably witnessed this stay apparatus in action. That slightly bent hind leg is often a sign they've locked in and are enjoying a light doze. It's a beautiful example of evolution solving a very practical problem. Horses needed a way to rest without sacrificing their ability to escape quickly, and their bodies delivered. So the next time you see a horse standing perfectly still, don't assume it's just zoning out. It might be deep in a light, standing nap, ready to run at the first sign of trouble. In their own way, horses have mastered the art of sleeping with one eye open, blending rest and vigilance into a single graceful posture.
Number 25. Elephants get about 2 hours of sleep per day. Imagine you're walking through the African savanna at night. The air is cool, the stars stretch endlessly above, and somewhere in the distance, a low rumble echoes. It's an elephant, still awake and on the move. While most animals would be deep in slumber by this hour, elephants are different. These gentle giants are among the lightest sleepers in the entire animal kingdom, clocking in at an average of just 2 hours of sleep a day. Yes, you heard that right. 2 hours. That's less than what many of us get after a terrible night tossing and turning. And yet, elephants seem to function perfectly well. Researchers have uncovered this fascinating fact using tracking collars and motion sensors on wild African elephants. These devices revealed that in their natural habitats, elephants don't curl up for long, luxurious stretches of rest. Instead, they sleep in several short bouts scattered across the day and night, usually adding up to only about 2 hours in total. In fact, if the situation calls for it, like during migrations or when they need to avoid predators, they can stay awake for nearly 2 full days without showing obvious signs of fatigue. So, how do they do it? Part of the answer lies in their lifestyle. Elephants spend a huge portion of their day walking long distances to find enough food and water. An adult African elephant can consume up to 150 kilograms of vegetation in a single day. To sustain that, they need to keep moving almost constantly. Time spent sleeping is time not spent eating or traveling, and for such large animals, that trade-off matters. Another key factor is safety. Even though elephants are enormous and have few natural predators, they still need to remain vigilant, especially at night when lions or poachers may be nearby. Most of their sleep happens while they're standing up, which allows them to wake up quickly and keep moving if needed. They've evolved to sleep lightly, almost as if they're dozing with one eye open. However, elephants do need occasional deep, dreamlike sleep, similar to REM sleep in humans. But this only happens when they lie down, which they do about once every few nights. During these rare moments, they enter a deeper, more restorative stage of rest, though it still doesn't last very long. Interestingly, elephants in captivity tend to sleep longer than their wild counterparts. In zoos or sanctuaries, where food is provided and there are no predators to worry about, elephants may rest for 4 to 6 hours a day. This contrast highlights how much their sleep patterns in the wild are shaped by environmental demands, constant movement, survival, and foraging. The fact that elephants can thrive on so little sleep challenges much of what we think we know about rest in mammals. Humans, for example, suffer significantly when sleep deprived, both physically and mentally.
But elephants seem to have evolved in a way that allows them to maintain complex social structures, travel long distances, and navigate threats, all while getting a fraction of the sleep we need. It also raises fascinating scientific questions. How do their brains handle memory consolidation, emotional processing, or physical repair with so little rest? Some researchers suspect that elephants may process information while awake, or that their short bouts of sleep are simply more efficient than ours. So, the next time you find yourself grumbling about getting only 6 hours of sleep, think about elephants. These massive, intelligent creatures roam vast landscapes, lead intricate social lives, and keep their herds safe, all while napping less than the average toddler. Their sleep habits are a testament to just how adaptable life can be in the wild.
Number 26. Koalas sleep around 18 to 20 hours each day. Imagine wandering through the eucalyptus forests of eastern Australia. The sun is warm, the air smells faintly of menthol, and high up in the branches, you spot a round, fluffy shape wedged between two limbs. At first, you might think it's part of the tree, a bundle of leaves or a big nest. But then you see a slow blink, a twitch of a fuzzy ear, and you realize it's a koala, fast asleep. And chances are, if you look again an hour later, or even 8 hours later, it'll still be sleeping. Koalas are among the sleepiest animals on Earth, snoozing for an astonishing 18 to 20 hours every single day. Yes, that means they're awake for as little as 4 to 6 hours, and even then, they don't exactly sprint around. Their waking moments are mostly spent climbing slowly to a new branch or chewing on eucalyptus leaves at a leisurely pace. This extreme sleepiness is actually a brilliant survival strategy. Koalas have a very specialized diet, consisting almost entirely of eucalyptus leaves. These leaves are tough, fibrous, and remarkably low in calories. They also contain natural toxins that require careful digestion. Unlike fruits or insects, eucalyptus doesn't provide a burst of energy. So, to make their meager diet work, koalas have adapted by conserving energy as much as possible. Sleeping for most of the day dramatically reduces the amount of energy their bodies need to function. Their digestive system is also specially designed for this lifestyle. Koalas have an unusually long cecum, which is a part of the gut that houses bacteria to break down the fibrous leaves and detoxify harmful compounds. But this process takes time and energy. So, instead of burning calories by being active, koalas let their digestive systems do the heavy lifting while they rest in their treetop napping spots. If you've ever seen photos of koalas, you'll notice how perfectly they seem to fit into the crooks of eucalyptus branches. This isn't accidental. Koalas choose branches that support their weight and help keep them stable as they sleep. Their thick, padded rumps act like built-in cushions, allowing them to perch for hours without falling. Even in the heat, their tree-hugging posture serves a purpose. Hugging the cooler trunk helps them regulate body temperature. Their long sleep cycles also help them avoid unnecessary movement during the hottest part of the day, which is especially important in Australia's often scorching climate. By remaining still, high in the trees, they reduce water loss and stay out of reach of many ground-based predators. When they do wake up, usually at night, koalas get down to business, slowly but steadily
munching through eucalyptus leaves. An adult koala can eat up to half a kilogram of leaves per day, carefully selecting the freshest, most nutritious ones. After a few hours of eating, they climb back to their favorite perch, tuck themselves in, and go right back to sleep. This sleepy rhythm might sound uneventful to us, but for koalas, it's the perfect way to thrive. Their entire biology is tuned to this unhurried lifestyle: low-energy food, minimal movement, and maximum rest. It's also part of why they have such a calm, almost serene presence when we see them. They're simply living at a different pace. So, next time you see a koala in a wildlife park or a photo online, remember, that adorable little marsupial isn't just being cute. It's carrying out a finely tuned survival plan. For koalas, sleep isn't a luxury, it's a way of life. 18 to 20 hours of it, to be exact.
Number 27. Lucid dreams aren't rare. Many people experience them. Imagine this. You're walking through a strange city in your dream. The buildings are glowing, the streets stretch out in impossible directions, and suddenly you realize something isn't quite right. This isn't real. You're dreaming. But instead of waking up, you smile. You decide to keep walking, maybe even take flight, just because you can. What you've just experienced is called a lucid dream, and it's not nearly as rare as many people think. A lucid dream happens when, in the middle of a dream, you become aware that you're dreaming. It's a kind of mental click. Sometimes, people simply recognize that the dream isn't real, but let it play out. Other times, they can actually influence what happens, gently steering the dream's direction, changing the setting, or even controlling their own actions with full awareness. Surveys suggest that about 55% of people have had at least one lucid dream in their lifetime. That means if you've ever had that sudden moment of clarity while asleep, you're far from alone. For some, these experiences are spontaneous and occasional, like a surprise cameo in the middle of a regular night's sleep. For others, lucid dreaming becomes something they practice and develop intentionally, turning their dreams into a kind of nighttime playground. Interestingly, children seem to experience lucid dreams more frequently than adults. One theory is that children's imaginations are naturally more vivid and flexible. Their sense of reality isn't as rigid, so recognizing and manipulating dreams may come more naturally to them. As we grow older, our dreams often become less vivid, and we're less likely to notice we're in them. But that doesn't mean lucid dreaming is lost to adulthood. Many adults actively train themselves to induce lucid dreams using specific techniques like reality checks during the day, journaling their dreams each morning, or waking briefly in the night to re-enter a dream state with more awareness. The experience itself can vary widely. For some people, lucid dreams are fleeting, just a few moments of awareness before they wake up or drift back into a regular dream. For others, they can last for what feels like extended periods, during which they can explore imaginary worlds, face their fears, or simply have fun. What makes lucid dreaming so fascinating is the unique mix of reality and imagination. Your brain is fully immersed in a dream environment, but your conscious mind, the part that usually takes a back seat during sleep, is suddenly present. It's like being the writer, director, and actor of your own movie all at once. Scientists are also deeply interested in lucid dreams because they blur the line between sleeping and waking states.
Brain imaging studies have shown that during lucid dreaming, certain parts of the prefrontal cortex, the area responsible for self-awareness and decision-making, light up more than in regular dreams. This gives researchers a rare window into consciousness, showing that awareness can emerge even while we're asleep. And contrary to what some might imagine, lucid dreaming isn't some forceful takeover of your mind. It's usually a gentle awareness, not total control. You might be able to decide to fly or walk through a wall, but the dream world still has a kind of organic flow. Many lucid dreamers describe it as collaborating with the dream rather than commanding it. For centuries, lucid dreaming has been mentioned in spiritual practices, literature, and philosophy. Ancient Buddhist texts describe dream yoga, a discipline of becoming aware during dreams to deepen spiritual insight. In the 19th century, European philosophers wrote about dream consciousness as a way of exploring the nature of the self. And today, lucid dreaming has found a place in modern psychology, meditation practices, and even therapy, sometimes used to help people overcome recurring nightmares by giving them a sense of agency inside the dream. So, while it might sound like something out of a sci-fi novel, lucid dreaming is actually a natural, widespread human experience. Whether it happens once in a lifetime or becomes a regular part of your sleep, it's a fascinating reminder that our minds don't just shut off when we rest. They build worlds, and sometimes, if we're lucky, we get to walk through those worlds fully awake while still asleep.
Number 28. Prolonged total sleep loss can be fatal. Imagine trying to stay awake for just one night. By morning, you're groggy, irritable, and your brain feels like it's running on fumes. Now stretch that out for several nights in a row. The world starts to blur, concentration falters, your body aches. But what happens if you never sleep at all? It might sound like the plot of a psychological thriller, but this is a very real scientific question, and the answer is stark. Prolonged total sleep loss can actually be fatal. We often treat sleep as optional, like something we can catch up on over the weekend. But for every animal studied so far, sleep isn't a luxury, it's a biological necessity. Take rats, for example. In landmark laboratory experiments, researchers discovered that when rats were completely deprived of sleep, they eventually died. This wasn't after months or years, but within a matter of weeks. At first, the rats became restless and hyperactive, almost like they were trying to push through the exhaustion. But as time went on, their bodies began to deteriorate. Their immune systems weakened, their body temperature regulation broke down, and eventually they collapsed. Similar findings have appeared in studies with other animals, like flies and mice. Recent research suggests that the cause of death isn't simply tiredness. Instead, toxic byproducts begin to build up in the body when sleep is withheld. Normally, during sleep, our bodies clear out waste, especially in the brain, where the glymphatic system flushes away metabolic debris that accumulates during waking hours. Without this nightly cleaning cycle, harmful compounds start to pile up, leading to widespread physiological damage. Over time, organs malfunction, systems fail, and the animal's body simply can't sustain itself. What makes this so haunting is that the process is quiet and gradual. There's no dramatic, obvious injury, no trauma, no infection. It's the slow unraveling of essential maintenance systems. Sleep acts like a kind of invisible caretaker, performing behind-the-scenes work every night to keep everything running smoothly.
When you remove that caretaker entirely, the body starts to fall apart from the inside out. Humans, of course, aren't subjected to these kinds of extreme experiments for ethical reasons, but history and rare medical conditions offer some chilling glimpses of what prolonged sleep loss can do to us. One of the most striking cases is fatal familial insomnia, a rare genetic disease in which people gradually lose the ability to sleep. As the disease progresses, patients develop hallucinations, organ failure, and neurological decline, ultimately leading to death, often within months to a couple of years. It's incredibly rare, but it illustrates in the most direct way that sleep is as vital as food, water, or air. Even in less extreme circumstances, the effects of sleep deprivation are profound. Severe lack of sleep disrupts everything from immune function to hormone regulation, memory consolidation, and emotional stability. In short, sleep isn't just rest. It's an active restorative process without which our bodies simply can't function. It's also worth noting that different animals tolerate different amounts of sleep loss, but none can survive without sleep indefinitely. This universality hints at something fundamental. Sleep isn't a quirky evolutionary leftover. It's a core biological requirement that has persisted across millions of years of evolution. So the next time you consider pulling multiple all-nighters or shrug off a chronic lack of rest, remember this. Sleep isn't wasted time. It's your body's most important repair window. Without it, the very systems that keep you alive slowly begin to fail. Sleep isn't just about feeling rested. It's about survival.
Number 29. Hypnic jerks cause that falling dream. You know that strange, almost comical moment when you're just about to fall asleep? Your body relaxes, your thoughts start drifting, and then suddenly your whole body jerks like you've just tripped over something invisible. Maybe your arm flails, your leg kicks, or you jolt upright with a racing heartbeat. And in that split second, you're convinced you were falling. This phenomenon is called a hypnic jerk, and if it's happened to you, don't worry, you're in good company. It's an incredibly common experience that many people have, especially as they're transitioning from wakefulness to sleep. Let's break it down. When you're falling asleep, your body goes through a fascinating shift. Your muscles relax, your breathing slows, and your brain starts producing different kinds of electrical activity. In this liminal state, right on the edge between being awake and being asleep, sometimes your brain misinterprets what's happening in your body. As your muscles go slack, the brain occasionally sends out a sudden, involuntary signal that causes your limbs to twitch sharply. That's the hypnic jerk. Here's where it gets interesting. Your mind often reacts to this sudden physical jolt by creating a dream, usually a very short, vivid one, where you're falling, tripping on a step, or missing a ledge. It happens so fast that the dream and the jerk feel like a single event. For example, you might see yourself walking down a staircase in your dream, then suddenly miss a step, and at that exact moment, your body jerks in real life, waking you up with that startled feeling. Sleep researchers believe this is your brain's way of explaining the sensation. It's almost like the brain quickly spins a story to make sense of the sudden muscle contraction. Instead of your body twitching for no reason, your mind says, "Oh, we must be falling." It's a fascinating example of how tightly linked our physical sensations and dream imagery can be.
But why do these jerks happen in the first place? One theory is that hypnic jerks are a kind of evolutionary leftover. Imagine our distant ancestors sleeping in trees or on precarious ledges to stay safe from predators. A sudden relaxation of the muscles might have signaled a potential fall, triggering a reflexive jerk to keep them from actually tumbling. Even though we now sleep on secure beds, that reflex may still be wired into our nervous systems. Other factors can make hypnic jerks more likely. Stress, caffeine, irregular sleep schedules, or going to bed overly tired can increase the frequency or intensity of these jolts. If you've ever had one after pulling a late-night study session or drinking coffee in the evening, that might explain it. The good news is that hypnic jerks are completely harmless. They don't signal any underlying health problem, and they're a normal part of the human sleep experience. Most of the time, you just shake it off, roll over, and drift back to sleep. What's truly remarkable is how this tiny split-second reflex gives rise to one of the most universal dream experiences, that heart-stopping sensation of falling, only to wake up and find yourself safe and snug in bed. It's a reminder that our brains are constantly weaving together physical sensations and mental narratives, even in the fragile moments between wakefulness and sleep. So the next time you jolt awake mid-fall, don't panic. It's just your body giving you a little nudge on your way to dreamland.
Number 30. Teeth falling out dreams often have simple causes. Imagine this. You're in the middle of a dream. Everything seems normal. You're talking, laughing, maybe standing in front of a mirror. And then suddenly, your teeth start to crumble. One by one, they fall out into your hands. You try to speak, but your mouth feels strange and hollow. Panic sets in. If that sounds familiar, you're not alone. Dreams about teeth falling out are among the most common nightmares worldwide. People in different cultures have been reporting versions of this dream for centuries. It's so vivid and unsettling that many have tried to give it deeper meanings. Some see it as a bad omen, a sign of illness or death in the family, or a symbol of personal insecurity. But modern sleep research paints a much simpler, less mysterious picture. These dreams are usually not predictions of the future, nor are they encoded spiritual messages. Instead, they're often your brain's way of translating physical sensations from your body into a dream narrative. Here's how it works. When we sleep, our brains don't completely shut off. They remain surprisingly aware of what's happening in our bodies. If something physical happens, say your mouth gets dry, you grind your teeth, or you have some discomfort in your gums, your dreaming mind often tries to make sense of that sensation by weaving it into the storyline of your dream. For example, a dentist once observed that patients who experienced nighttime mouth discomfort would sometimes dream of their teeth crumbling or falling out. It's not that their teeth were actually falling out, it's that their brains were picking up real sensations and turning them into a dramatic image. It's a bit like how your alarm clock in the real world might become a ringing phone in your dream. The brain takes raw sensory input and dresses it up in dream imagery. Losing teeth is such a distinct, emotionally charged symbol that it becomes the perfect way for the dreaming mind to represent discomfort in the mouth. Other common triggers include dry mouth
which can happen if you breathe through your mouth while sleeping, or bruxism, the medical term for grinding or clenching your teeth at night. This habit is surprisingly common and can be mild or intense, sometimes even causing headaches or jaw pain when you wake up. Cultural beliefs have also added layers of meaning to this dream over time. In some traditions, dreams about teeth falling out are seen as warnings of upcoming misfortune or even death, but there's no evidence to support those interpretations. In fact, across cultures, these dreams are so widespread and similar that they're better explained by shared human physiology than by mystical foresight. Psychologists have also explored emotional interpretations. For some people, these dreams may reflect feelings of vulnerability, aging, or loss of control. After all, teeth are tied to appearance, communication, and strength. But even these symbolic interpretations often come second to the basic physical triggers that set the stage for the dream in the first place. The key takeaway is this: if you dream about your teeth falling out, it doesn't mean something terrible is coming. More often than not, your brain is simply responding to what's happening in your mouth while you sleep. Maybe you need a sip of water. Maybe you've been grinding your teeth, or maybe your gums are just a bit sensitive. These dreams feel intense because losing teeth is universally unsettling. It taps into deep, primal anxieties. But once you understand the science behind it, the fear tends to lose its bite. No pun intended. So the next time you wake up after a teeth falling out dream, instead of worrying about hidden omens, it might be smarter to check if you're dehydrated, or maybe schedule that overdue dental checkup. Sometimes our most dramatic dreams have surprisingly ordinary causes.
Conclusion. As the night deepens and the world around us slows to a gentle hush, it's easy to think of sleep as a quiet escape, a blank space between one day and the next. But as we've explored together, sleep is anything but empty. It's a time when our bodies repair, our minds weave intricate stories, and ancient biological rhythms carry us through cycles that have shaped human life for millennia. From the tiniest newborns dreaming their way into growth, to the intricate nightly cleaning shifts that keep our brains clear, sleep connects every living being in subtle, extraordinary ways. Even our pets beside us, the dolphins in the sea, and cultures across history have found their own rhythms in this shared human and animal need. So tonight, when you lay your head on the pillow, take a moment to appreciate what's happening behind the scenes. As your breath slows and your eyes grow heavy, a vast, silent world begins its work, restoring, remembering, and creating. Sleep isn't simply the end of your day. It's the quiet heartbeat of life itself, gently carrying you into tomorrow.